Disability is random. It is caused by many factors, including genetics. While having a disability is seen to be a disadvantage to lead a normal life, many have proven otherwise. They are superhumans having an invisible hand of support.
If you have seen the Paralympic Games, you would realize that most of the sports use wheelchairs. I'm not going to deny the practice and determination that has led these athletes to their success, yet, engineering has equally contributed. So, today we are going to see how engineering brought the wheelchair sports to the next level.
First up is the very design of the wheels used. From an open view, you may think there are not many options to modify a wheel, but that's not true. Handful of factors like mass, size, and orientation of the wheel can cause huge differences in the outstanding performance of Paralympians. The lighter the wheels are, the lighter the wheelchair is.
That's where the first improvement comes in. We all know a lighter box will be easier to handle than a heavier one due to its gravity. Engineering manifests this simple information to provide the athletes with wheelchairs of the lowest possible masses, keeping the strength in check.
If you are aware, the wheelchairs used in Paralympics have a different design as a whole. The wheels are slanted to make an angle with the ground. Well, it's just a simple flick of orientation that gives the wheelchair a larger base, which accounts for its higher stability, right? Surprisingly, it's just the tip of an iceberg. Let's recall the topic of moments about a pivot. Moment is the product of force and perpendicular distance from the pivot. So, if the wheels are inclined too much, the wheelchair may collapse when there is greater moment. So, maybe the idea of inclined wheels is also about keeping the wheelchair from collapsing by the pivots of the attached wheels.
Before we could go any further, head on to our channel to find more interesting videos. Do not forget to subscribe to our channel and ring the notification bell so that you won't miss any of our videos. Next up, we have the size of the wheel, or more specifically, its radius. This goes back to the very knowledge of connection between radius and circumference of a circle. The vague idea here is that we have to provide them with the largest possible wheel. Firstly, it's easier to move a larger wheel, though that's debatable. Secondly, it also travels the extra inch literally.
Back to circles. The larger the radius, the larger its circumference. Imagine if we laid the outline of a circle straight. The one with the larger radius will have a longer line. This is the core of the idea. Since the wheels spin to mobilize the wheelchair, the straight line will be the movement path. In simpler words, one spin of a larger wheel can travel double the distance traveled by a spin of another wheel with half the initial radius. Spare a moment to take that in. It's like how people with longer legs can have larger steps when running, except we are talking about wheels.
We are done with the wheels. Left now is the seat. We think of the seat as the place to hold the user. Indeed, it is. But the material and the position of the seat on a wheelchair can do a lot for the athletes in the Paralympic Games. The genius of engineering is yet to be unfolded.
If the seat is elastic, the user will lack comfortability, especially after aggressive movements, because it will stretch a long way before the user gets to the rest position. However, if an inelastic material is used, the impact will be hard enough to damage the parts of body in contact with the seat as it will be rigid. So, engineers give a solution by confirming the right material which fulfills the purpose, being somewhere between elastic and inelastic. Example of such suitable materials for Paralympians is polypropylene. This in turn pushes the athletes further with advantage.
The way a person sits carries too much details. For example, if the back is right up, the person is most probably active. A crouched back may indicate a more tired posture. This varies with the requirement of sports in Paralympics.
Sprinters lean forward naturally to allow a more aerodynamic posture, perfect for acceleration. Unfortunately, it may be even harder for the athletes in Paralympics due to their limb disabilities. By setting up the seat in a way that it fixes the user to advantage is what engineers do to relieve the burden of the athletes and giving the edge nature failed to give them.
Engineering is the art with which we correct the flaws of nature. By doing just that, people who we thought to be disabled, along with passions for success, are now unstoppable and more powerful in terms of physicality. Their success was due to their effort. Still, innovation was definitely a catalyst. Thank you for watching. If you liked this video, please show us by giving a thumbs up or leave your thoughts in the comment section below. See you soon with another catchy video from Quantum Vimana.